Hey Calc students, welcome to Ms. Baker's first screencast of exponential functions. Exponential functions are of the form y equals a times b to the x. That didn't come out very well, so let's try writing it in. Y equals a times some b that's raised to the x. Right? The variable x is an exponent. Graphs aren't straight lines. In a straight line, the rate of change is the same across the graph, but in these graphs, the rate of change increases or decreases across the graphs. An example, y, that didn't come out very well. Y, yeah, I'm still getting used to the pen. Y equals 100 times 0.5 to the x. In this graph, a is equal to 100, b is equal to 0.5. A is greater than 0, b is between 0 and 1, so the graph will be decreasing. In each case, each time x is increased by 1, y is going to decrease to 1/2 of its previous value. And the graph will look like the one in the middle. There we go. That's a graph of that function. Another example, and not so clear, y equals 1 times 2 to the x. In this case, a is 1, it's greater than 0. b is greater than 1. Our graph then is going to be increasing. So each time x is increased by 1, y increases by a factor of 2. Let's talk about growth and decay for a second. In particular, a growth equation might be a plus 1 to the r raised to the x. A is the initial amount before measuring growth or decay. R is the growth or decay rate, it's often a percent, and x is the number of time intervals that have passed. So, if I have, for example, a bank account balance B for an account starting with S dollars, earning an annual interest rate R, it's left untouched for N years, it can be calculated as B equals S times 1 plus R. B equals S 1 plus R to the N. And that's an exponential growth formula. I want to find a bank balance to the nearest dollar. If the account starts with $100, has an annual rate of 4%, and the money is left in the account for 12 years. So my balance, B, would be equal to my starting amount, which is $100. 1 plus my 4% is 0.04, raised to the 12th. And I do my magic math, and that's going to come out to be $160. Okay. Another problem, in 1985, there were 285 cell phone subscribers in the small town of Centerville. The number of subscribers increased by 75% per year after 1985. How many cell phone subscribers were there in Centerville in 1994? Don't consider the fractional part of a person. So our general equation is f of x equals a times 1 plus r to the n. My f of x would be my starting value, 285, times 1 plus my rate is 0.75 to the n. Now, if I substitute in 1 year, I will end up with 498 subscribers. And if I substitute in, I want to know how many there'll be in 1994. which got cut off of my table, but that's 10 years later. I would substitute in 10. I would substitute in 10. I would have 285, 1 plus 0.75 to the 10, and that will come out to be, oh yes, check my calculations, 43,871 subscribers.